Properties of logarithm. Exponential / logarithmic form properties. For a greater than 0, b greater than 0, and b not equal to 1. The equations log base b of a equals c and b to the c equals a are equivalent. And we have some examples. Be aware, some of these examples I've tried in different videos. So log base 6 of 36, the equivalent is 2. In other words, we can always convert that into exponential format by saying 6 to the power of 2 would give us 36, right? So 6 times 6 is 36. So you'd convert back and forth depending on what values you need to find. Log base 2 of 32 equals 5. So in other words, 2 to the 5 would give you 32. In other words, if you multiply 2 times 2 times 2 times 2 times 2, that should give you 32. And log base 3 of 81, well, that equals 4, because we can always convert it to exponential. To say 3 to the 4th will give us 81. So 3 times 3 times 3 times 3 would be 81. You're welcome to check it with your calculator for reference if you want to. So, quick turn on your calculator. Let me clear out of this. Second mode will give us out of there if you can't get out of there. So you can go 6, the caret key right there below your clear button, power of 2. And it should confirm that it's 36. 2 to the 5th, so 2, caret key 5, hit enter. Should confirm that you get 32. 3 to the 4th, caret key once again, and enter should confirm that you get 81. So yeah, it works. You can convert them back and forth and check with your calculators in some cases. So be aware, in the past we were using log base b of a equals k and b to the k equals a. The only difference, well, there is no difference reality other than what variable you name it. In other words, here the k has become a c. And that's not a huge deal. It's still the same expression, same equation, whether it has different variables or not. The state of the form is still the same. So we can change it to a c in both cases and still say that you can work back and forth between them, right? So there are inverse functions of each other or inverse expressions. So something to be aware. They still work well together. So let's try some examples. So the question is, can you solve by writing an exponential form? Once again, let's write our basic formulas. Highly recommend you write your formulas at the top of your page whenever you're working on homework. Agreed? So log base v of a equals c and b to the c equals a. And keep in mind that you can convert back and forth between them. So first case scenario, a, we have log base 4 of x equals 5. So therefore we can convert this. Agreed? Looks to be fairly straightforward, converting. Our base is 4, and the a value is 5, therefore the exponent will be, well, pardon me, the a value is x, right? So therefore the exponent is 5, I should say. So 4 to the 5th equals x. And this is something you can consult with your calculators. So your calculators, clear out your calculator if needed, clear. 4, push the caret key, put the 5 on there. And notice once again T84s automatically raises it for you. T83s and some 84s don't, but most T84s do. So 4 caret key 5, hit enter, and that gives you the value of x. X is 1024. So in this case, we've just found out that the x value is 1024. So there's our answer. So we can solve by converting from log into exponential format. Let's go for b. b, log base 3 of 2x plus 2 equals 7. Do notice the 2x plus 2 is in parentheses. It looks a lot more complex than before, right? Well, in reality, it's no different. The only difference here is we're converting still. But we have an extra step afterwards. So conversion, our base is 3 and it's 3 to the power of 7 because that's the c value. Agree? The c value is 7. And the base value is 3. What's in parentheses is 2x plus 2. So we have 2x plus 2 in this case on the other side of our equal sign. And now we're just solving. So from here on, it becomes quite a bit more straightforward. So let's take the 3 to the 7. So 3, caret key 7, hit enter, and that gives you your value of 2187. So now we can go to the next step, which is to write down the value. 2187 equals 2x plus 2. From here on, it becomes really straightforward. It's a solving for x type of problem. So let's get rid of the 2, the one that's being added. Remember, opposites of OR operation to make it easier to solve. Addition and subtraction go first. So minus 2 to both sides of our equal sign. Plus 2 minus 2 cancel out. 2187 minus 2 now gives us, and I'll write over here on the left side, 2185. So 2185 equals 2x. The only thing remaining with the x is the 2. So time to get rid of the 2. Opposite of multiplication, remember, if there's nothing between the 2 and the x, it implies multiplication. So the opposites divide by 2. What we do to the right side, we must also do to the left side. So divided by 2185 divided by 2. 2 divided by 2 cancels out, and that gives us 2185. You could check with your calculator real quick. 2185 should give you 1092.5 roughly, agreed? And that becomes our x value. So there is our answer. Once again, real quick check. 3 to the 7 give us 2187 minus 2 will give us 2185 divided by 2 will give us 1092.5, which is our answer there. Agreed? So let's go on to the next one then. C. We have 3 log base 5 of 4x plus 1 equals 9. The only difference here is that we have a 3 stuck at the beginning of the log base 5, right? Well, it's not a huge deal. Remember, you can always get rid of it by doing the opposite. But what's the 3 doing with the log? Well, it's just like whatever it would be doing with an x afterwards, right? So it'd be like it's multiplication, in other words, because there's no addition, subtraction, or division sign in between. So opposite of multiplication, let's divide by 3 then. What we do to the left side, we must do to the right side, right? Both sides. 3 divided by 3 cancels out, and 9 divided by 3 will give us 3. 3 times 3 is 9, right? And that gets rid of the 3 from the left side. So now all that we have left is log base 5 of 4x plus 1 equals 3. Now we can convert. So let's convert in this case. Let's see, our conversion. Our base is 5, exponent is 3. And what's in the parentheses? 4x plus 1 is on the right side now. Once again, we have our conversion formulas at the top if you care to reference them, right? So do reference them since they're at the top of your page as well when you're working on homework. So 5 to the third, this becomes a calculator. Okay, so let me clear it out and state that we have 5 caret key 3, agreed, hit enter, and that should give us 125. So it should give us 125 equals 4x plus 1. So let's try that. 125 equals 4x plus 1, and from here on it's pretty similar to the previous problem. It becomes a solve for x type of problem now. So let's get rid of the 1, right, because it's being added. So minus 1 from both sides. 125 minus 1, the 1 cancels out on the right side. 125 minus 1, 124. And now 124 divided by 4. This is where, once again, where your calculator comes in handy. So we have 125 minus 1 gives us 124 divided by 4 will give us 31. So there we go. Our answer in this case, x equals 31. Going for the next one. So D, we have log base 4 of x to the 5th equals 3. But just like before, we're converting. This one's back to being the straightforward format. Converting then. 4 to the power, notice the 3 is the c value, right? So 4 to the power of 3 equals x to the power of 5. X to the 5 was in parentheses originally. So 4 to the third becomes something you can apply in your calculator. Real quick for reference. On your calculator, 4 caret key 3, hit enter, 64. Okay, so 64 equals x to the power of 5. But now we want to get rid of the 5. How do we get rid of the 5? Reciprocal, right? Reciprocal of 5. In other words, exponential root, 1 over that number. 1 over 5, right? Since that's what we're trying to get rid of. What we do to one side, we must also do the other side, 1 over 5. Remember, it applies to everything on the other side. So it becomes 64 to the 1/5. So let's try to put on our calculator, 64, caret key. I recommend you put parentheses for this case. Open up a parentheses, 1 divided by 5. Close your parentheses and hit enter. That gives you your answer now. Note that 5 times 1 over 5 cancels out, agreed? So let's cancel it out. And that gives us just the x equals, and we're roughly rounding it to 2.3. It's 2.29, so we might as well round it to 2.3 roughly for this case scenario. We're not too worried about the exact value in this case, agreed? So be aware of that. That's why we rounded to 1 decimal, but the more critical the value is, the more decimal places we want to include. Okay, so let's go on to the next portion of this. Power property for logarithms. For x greater than 0, b greater than 0, b not equal to 1. It's similar to what we saw up above, right? Or previously, I should say. Log base v of x to the p is equivalent to saying p log base v of x. Well, you may have heard me mumble it before in previous videos if you've seen them. But otherwise, in short, a logarithm of a power of x is the exponent times the logarithm of x. So in other words, to keep it simple, a log allows us to bring down exponents as long as it's a common exponent. Be aware of that. In this case, since the x is the only thing that exists in the parentheses and it has an exponent of p, we are allowed to bring it down as a multiplication. So it becomes a p times the log base v of x. So let's try the previous example that we saw in part D, and let's see how it works out. So once again, this is the same problem as before, agreed? So let's see. I'm just copying down the problem. This is exactly what we had last time up above. For D, we have log base 4 of x to the 5th equals 3, and we converted it to 4 to the power of 3 equals x to the 5th. And likewise, we then took 4 to the 3rd, gave us 64. And we took the reciprocal of 1/5 to get rid of the 5, or exponent of 5 from the x, to solve for x. So that gave us 2.3 equals x. Once again, this is just what we previously did. Okay? So now let's try this second format. So this second format, using the logarithmic property, okay, so power property. Log, once again, base 4 of x to the 5th equals 3. It's the same problem as before, exactly the same. The only difference is in this case we're going to take the 5 and use the power property to bring it down, since a log allows us to bring down an exponent. So now let's bring it down, and it's going to say 5 times instead. It becomes a multiplication. So 5 times the log, and let's not forget the base on that one, log base 4 of x equals 3. So now we're going to end up doing the pretty similar steps as before. Now the only difference here is we brought down the exponent. Sometimes it's useful to be able to bring down exponents. So let's get rid of the 5 by division. So we divide both sides by 5. Cancel the 5 on the left side. And now let's go ahead and proceed. On the left side, no 5 exists anymore, right? We got rid of it to the other side. So log base 4 of x equals 3 divided by 5. And now we convert it. As we convert it, note that the base is 4. And the exponent is now 3/5, right? Because that's what the c value is. It's on the other side of the equal sign on the left side, right? And now we've completely solved for x. Notice we avoided a minor step from before. That's about it. Be aware. So you have 2 options on how to do it now. But otherwise, 4 to the 3/5 should give you the same result, 2.3. And just for you to believe it, we'll try it again. We're going to write 4, caret key, open parentheses, 3 divided by 5, close your parentheses, and it should give us the same values right above, 2.2973, etc., right? Or roughly 2.3. So we definitely get the same value, same answer. So it works both formats. I'll leave it up to you which format you prefer. Agreed? So once again, we get same as before, or same value as previous.